is Peter Crank. I'm a PhD candidate here in geography, and I have been using R for a while now, starting my master's and then moving into my PhD. So I'm just going to go through some basics here at the start about R, just to kind of get us all on the same page. If you have questions, feel free to use the raise hand function with the participants, there we go. Or you can put it in the group chat, or you can just also use your microphone and interrupt me. That's totally fine as well. So what is R? I joke that it is a pirate code because it's just R. But it is an open source statistical and computing language software. One of the nice things about it is in that it's open source means that anybody can create new functions and features in it, and then can share that with the community. So R is rapidly becoming one of the main statistical softwares that people use because most of the other ones are proprietary, but also because there's a lot of different disciplines that use it and are working to put in their own functions and capabilities within it. So people in oceanography to human geography to epidemiology and everywhere else in between and around those use this. So it's a really useful skill or language to be familiar with because you can use it when you work interdisciplinary types of research as well. So some of the things that it does, it can do numerical or quantitative analysis. You can do data management, data visualization, spatial analysis, and spatial visualization, as well as qualitative analysis. So again, the strengths of it being open source is that it can do almost anything if you know what to do and how to do it in R. Whereas other softwares are going to be a bit more limited in that regard. So generally, this is sort of the overview of where we're going. We'll start with what working directories are and how you would script in R and the different files that are associated with, file types that are associated with R. We'll talk a bit about packages, how to import data sets, maybe some basic table transformations and data manipulation, because always whenever we are getting data from somebody else, we usually have to do some sort of data cleaning to it. I'll go through some basics of plotting data, mostly using the tidyverse packages. We can go through some basic statistics and histograms with that as well. I'll talk a bit about data exportation, how you can export your data as tables. You can export your images and graphs so that you can then easily import them into PowerPoint slides, Word documents, manuscripts, etc. And then I'll also, if we have time, get into a bit of map making as well, since most of us are geographers and almost everybody at some time or another interfaces with maps. So from the computer programming side, working directories are essentially where you function within R. Let me briefly exit out of this and see. Are you guys able to see now my R Studio workspace? Or is it still, oh, looks like
no, I'm still seeing the PowerPoint.
No, I still see the presentation.
Okay, let me pull this one up and see. Can you see this one now?
Yes.
Great. Okay, so in R, you have your scripts, you have a terminal, a console, which is down here at the bottom. But then in R Studio on the right, you have what we call, well, you have files, plots, packages, a viewer, and help. But in those, all of them have what we call a working directory. And so in this instance, I'm setting up a specific working directory, which effectively tells R, look in this specific folder for any scripts that I want to run. But that's also where it's going to output things unless you redirect it. So when you're saving things later on, that's where it's going to go to. So I'm going to move this to the working directory. So in the working directory, then you're able to store all of your data. You can store your output. You can store your scripts, and they're all in one location. And then you can anytime you reopen R, you can automatically open to that space. Our projects, which let me flip back to the other one. Our projects are a way of doing that with a single larger file structure. So if you go in here, I can make so you have a bunch of different projects that you can make. You can also make a new project, which is this top one here. Don't need to say that at the moment. And so you can start in making new directories. You can pull in from an existing one. You can also keep track of it using version controlling within R. So typically, if you're going to be starting on a project and you wanted to use R with it, it would make sense to put all of the data, files, etc., that are associated with that project into one R directory. So that you click that directory from your regular file folders, and it will automatically open up RStudio, and you will automatically be in the right, searching in the right places to be pulling out the data that you want. So that's really helpful to keep everything together and on track. We'll go back to the PowerPoint. So in R, there's a few different file types that you can use. The basic one is a .r file. This is what you would use if you were using just R and not incorporating RStudio. A few other files that you can use are R Markdown or R Notebook. And those have different file extensions. R Markdown is the .rmd. And those allow you to do a bit more with the code. Using a Markdown file means that you can actually export both the code, the output, and any notes that you make along the way as an HTML, Word document, or a PDF. And so people can actually write a full manuscript for a paper in R using R Markdown and export it in LaTeX, formatted exactly the way that they want it to. So there's a lot of handy post-processing things associated with R Markdown that you can take advantage of using that in R. Packages are families of functions that make life easier. One of the ones that we will use today is the Tidyverse package, which is multiple packages, but all of them work together to give you more power and easier flow between different portions of your analysis, whether that's data cleaning, manipulation, and then visualization as well, can all be done within the same family. And that makes it a bit easier because your coding is consistent across those and it reads it in appropriately. Also, the computer programming side includes the importing data sets and table transformations. So again, working directories is where you're going to find all these scripts to pull in and data to pull in for analysis. If you on your own wanted to type in get WD, open, close parentheses, in your console, which is at the bottom, that will then tell you where you currently are. So let me flip back to RStudio myself. So I've already said it, but if I were to type in get WD, so it's down here at the bottom of the screen is where it's on my RStudio, and I hit enter, it will then return the file location that R is currently looking at and pulling from. So if you're trying to pull in something and it says that it can't find it, you might want to just check and see what your working directory is, because the default isn't necessarily your desktop. Usually it's some other place within your computer. So if you wanted to and then redirect your working directory to a specific location, the function is set WD or set working directory, which is what I had done previously. And you'll need to use quotation marks around the location to be able to set it to a specific file. So that's how you would set it once you have those things in place. In addition to, again, the working directories, you have those R projects. Again, this is where you can store your working directory and all of your scripts. And again, you can just go to File, New Project to get that one working. And it has an extension of RPROJ, so you know what that one is. So here's just an example again of R scripts, is the one that we're looking at here. R Markdown is the second one. So there's a bit more stuff going on, but you can actually use that to access data through FTP, as well as then moving it into an analysis stage and using R to do that. So a multifunctional file and script type with R Markdown. So in the packages, there's a bunch of different ones. These are the main ones that I'll be using today. I think there's a couple more that I'll pull up later on, but for the most part, these are going to be your main ones. Tidyverse, TMAP tools, and GR devices are going to help with the exportation and mapping side of things. So if you haven't downloaded any packages before in R, the easiest way to do that, or the simplest way, I guess, is to go into your console and type in install.packages, open parentheses, and then in quotation marks, type the name of the package that you're wanting to use. So I already have these installed, but for example, and you can see them all up at the top here in my script itself, is Tidyverse is one, US Map is another one that we may use, GGMap, Maps, Map Data, and GGSN. To import multiple packages at the same time, or install multiple packages at the same time, you simply put a comma between each of the packages. So we'll put in maps as well. So I'm not going to restart mine on that one. But it'll, once you go through, it will begin to pull those in. And it may take a minute with the Tidyverse one specifically, and it may even ask you to reinstall. But once you have those installed onto the computer, you still have to load them into your script to begin working in them. And that's what the library function does, is that it allows you then to take what has been downloaded and then begin to use it in your working session that you're in. So make sure I'm not forgetting anything off of my PowerPoint. So yeah, those are the various ones that we'll use. So if you want to take a moment and on your own, just type in install.packages, open parentheses, quotations, the name of the package, and then hit enter in your console. And that should then begin the process of installing the R package. It'll pull it from the closest supercomputer that R is running out of. When I looked at it earlier this week, the closest one geographically to us is out of Oregon State, but here in Arizona. But if you're at other places, you may want to use a different source just because you are physically closer to it and may install quicker. So any questions at this point? I know it's sort of early on, still getting used to what RStudio is, but I want to check to see if you guys are good handling things?
One quick thing, Peter, it's something that tripped me up a lot when I started with R. So if you're new, like if you were in like your normal Windows file folder and you try to copy and paste that into your working directory, the backslashes will throw you off. And that was something that took me a while to remember. So
yeah, so depending on if you're on a Mac or a PC, will depend on how you function these things. So I'm working on a PC. So I use, everything's basically off the C drive. So it's C : and then forward slashes. I always forget the name for which one. This slash is what you would use in both Windows and Mac. But the default with Windows, if you were to just copy it straight from your Windows File Folder Explorer, would be the other one. And that one's not going to work because that is an actual command within R to do specific things. So if you use that one, it gets really confused along the way. Yeah, so you have to flip your slashes to get those to work correctly. Thank you for reminding me on that one, Zach, that's helpful. So, let's see if I can get this to not wanting to. Okay, all right. We'll terminate that in a moment. To move into reading in tables and reading in data, a lot of the data sources that I use are typically already in a comma delimited file format. And that's fairly common. And the easiest way to pull that in is to use the read _ CSV command. You could use, there's another one that's read.csv, and both work. The read _ one, though, is specifically out of the tidyverse package, which means that it imports it in a manner that's more easily used within that suite of packages. So that's usually the most common one. Sometimes, though, you do have weird formats, such as ones that are space delimited, tab delimited, but also ones that simply have they're a fixed width format, where they throw all the information together and they simply give you a metadata file that says column 1 is this many space, this many characters, column 2 is the next one. You can also read those in using the read _ FWF, or fixed width format function. And in that, you will have to spell out exactly what the widths are. But that should be something that you can pull up if you were using that, needing to use that data set yourself. So just as an FYI, that may be something that comes up that you can use, but isn't necessarily one that's going to pop up for you, but it can be useful. Yeah, usually once you have that data imported, you will need to clean it. Sometimes it's simply identifying the missing data or changing a data type to be numerical, character, or logical. Those are the 3 most common types. A 4th type is that you may want to import a column that has date and or time in it, and you'll want to then adjust that column to be read in as date or time, which we'll get to. Once everything's in, and again, I will go over to my R scripts in a few minutes and we'll walk through a bit more of these in detail. But once you have it in, you can then plot data to get a handle on what the data looks like. You can do basic stuff like mean, median, and mode. You can do histograms, regressions pretty quickly and simply within R. This is just an example of one that I have from previous research that's almost finalized. Just an example of being able to pull in data and create various types of plots using the data that you have. And all of these are done using code within R and then can be copied and pasted out. So plotting can be done through base R using the plot function. I tend to use ggplot, which comes out of the tidyverse. It has a pretty clear language and grammar setup to it that breaks apart various components of the plot from each other, so that it's a bit easier to figure out what is the problem and how to make adjustments and tweak your images. So this one is just using basic R, using the plot function. And this is the function syntax to it. So you first have to tell it what your X is, your Y, the type of data that you're using, Main is going to be your title, subtitle, label for your Y, label for your X. And so you can convert it, or you can import the data and then get plots like this using R, its base plot function. You can also modify things like coloring, sizing, and those types of things. But you can also, ggplot does the same, but does it a bit with a bit cleaner a look to it. Basic statistics, again, mean, median, mode is there, max, min, histograms, as well as linear regressions are all possible. So again, this is just out of R. The base plotting functions can create stuff like this, where you can change the colors, you can adjust the times, you can add in, you can do histograms to get the distribution of various data sets. In this example, I've taken minimum temperature from the airport here in Phoenix and plotted the past 80 years or so. And that's the orange lines, but then I added a regression line to simply give me a linear regression for how temperature has changed over the past 80 years here. This one's a bit harder to read, but this one has multiple regressions on it. So you can also layer on top of your base map or your base graph multiple additional analyses on top of it. And then you can also export tables, graphs, and text. I think, yeah. Just like you read stuff in with read_CSV, you can export tables out using write_CSV. And again, I will walk through these in R in just a moment. But you can also write graphs and images directly to a JPEG or PNG file. And you can also tell it what widths and heights you want the number of pixels to be. So then you can more easily customize things. This link down here, which you can, I'll send this out to you guys afterward. You can actually go through this link and actually pull an older version of this workshop that I've done that has the language and the function and script on that as well. But you can also do a whole lot more using R Markdown and such. So tidyverse, which I've mentioned before, is one of the more popular, but also one of the really powerful additions to the basic R packages. So tidyverse is used for data science. That is its main purpose. And it imports multiple different packages into your R studio or your R workspace using the tidyverse. These are the main 6 that are used. It's reader, tidier, per, tibble, dipler, and then ggplot. TidyR and readr are the ones that are really useful for the initial pulling in and exportation of data sets. So reading in CSV files or TXT files, or exporting CSV or TXT. TidyR works with some data manipulation sides of that. And then Tibble is a specific table packaging where you can convert your basic tables into a Tibble, and then that gives you more flexibility within this tidyverse of being able to use those data sets and manipulate them. And then ggplot is the visualization component of that. And then dipler is sort of in the background working out some of the kinks that can occur along the way. So that's what tidyverse is, and then is commonly used across a wide variety of disciplines. So those same images that I showed earlier using rplot can be redone using tidyverse. It can make them a bit smoother and a bit more eye-catching as well. So in this example, I have Phoenix daily temperatures, the maximum and minimum temperatures, as histograms plotted on top of each other. So that you can plot multiple things on top of each other very, very easily, and then quickly create legends associated with that. In tidyverse, it's also really easy to not just do a linear regression, but you can do a generalized, a GLM or a GAM model that can then allow for polynomials that can describe your data as opposed to just a linear model. And you can use a linear as well. And you can stipulate that within tidyverse, but tidyverse is more flexible early on to be able to handle different types of relationships. So I'm gonna step out, and if we have time for a lot of map making, then I will come back to the map making in R, but I wanna make sure that everybody is comfortable with just the basics within R. So, can you guys see my R Studio again? I wanna make sure I'm on the right screen for you guys. Nope, okay. Let me go back. Okay, should be able to see the R Studio now. I've highlighted just the first couple of lines in it. So in these lines, I'm setting up the working directory, and I am getting my workspace ready to use any functions that are associated with these different packages. So one of the ways that you can run lines of code within R is you can use the GUI and just hit run at the top. But the other option is Control-Enter will run any highlighted sections of code. If you're on if you haven't highlighted anything, wherever your cursor is, Control-R will run that line as well. So if you go in and you have downloaded all of these different packages, and then you run the library function for each, it will load all of those packages, and then at that point you can then use any functions that are associated with it. So to start, I want to read in the data set. So I'm using read dot or read underscore CSV, either one works. And then what this function in front of it is doing, na.omit, is telling as it's reading it in, to make sure that it is, if there are missing data points, to go ahead and omit those, so that all of the data that we are pulling in is the actual data itself. You could do this later on if you didn't know that there were NAs, you could do this later on. You could also, if you really needed the NAs to be in there, you could do this later on as well, and maintain your non-existent data throughout the time that you're analyzing. So I have, using this arrow and dash function, is effectively saying read all of this data in and put it into this variable. So I call it daily.min.max. And you can see that now under the data in my, to the right-hand side, I now have a variable or a table effectively that has all of this data in it. And you can see then that each column has different things. There's 3 columns to this data set. The first column is currently listed as a factor, which I will need to change. And I can show you that one by using this class function. So if you hit class of daily.min.max, it will tell you the class of the entire table. The $sign allows you to single out an individual column within that data set. So if I use that for the date column, it then will tell me that the type of data that is in that column is a factor data set. And factor is useful, but it is not useful as a date, because you can't tell it to search for the months of June, or only look for Christmas Day if you were looking at specific dates within your data set. So one of the functions that's useful within base R is the as.date function. And in that, you simply tell it what column you want to reformat, put a comma between that, and then how you want it to be formatted. So in this setup, I am telling it to reformat the date column as data that are reading in as day, month, year. So, and then I'm telling it to put that back in as my new date column. So if I run that one, and then I do the class function again, it now shows that my data are, instead of being factor, they are now as a date. And so now it will begin to read in these data as dates, as opposed to simply a list of numbers with dashes associated with them. So one way to check to see your data and how it's formatted is to use the view function. I could do just simply view and then daily.min.max, but head will only pull out the first few rows of the data, which can be nice when you're using a very large data set, because otherwise it may take a while to load. But instead, I can simply see the first 6 rows, and I can see, yes, this is 1933, June 1st is what it's reading. Maximum temperature in Celsius, minimum temperature in Celsius. So I can then see what my data is formatted as, and that's helpful as I begin to try and plot things. So to make the initial histogram plot using ggplot, this data set or this package and function uses ggplot, and then you need to first tell it the data that you want to import and what you're wanting to use. So using the daily.min.max data set, you simply import it there, and I then close the parentheses in ggplot and then put a plus sign. So one of the fun things about, or the helpful things about ggplot is that in ggplot, you want to tell it what data you're pulling from, but then you can add on functions using the plus sign. So you can add on various things like a histogram, and that will then map the histogram based on what data set you want to use. So within a histogram, you want to tell it mapping, effectively telling it what it's going to be pulling in. And then AES is short for aesthetics, basically what makes it look, or how it looks. And since we're doing a histogram, you always have an X file, or an X label, but your Y is always your frequency. So in this instance, I'm telling it plot a histogram of maximum temperature. And then the one below it, I'm adding on a minimum temperature histogram. So to show you what that would look like without the minimum there, within R, the pound sign or hashtag writes off that line as simply comments, and so R does not read it. So if I then simply, and I'll remove the plus sign for the moment, if I hit Control R at this point, it's going to save both the ggplot line, but also this geom histogram line as temp.hist. And so when I do that, I can then down here at the bottom in my console type in temp.hist because it's now an object over here in my data set. And it then begins to plot that. So we can now see here in the plots, we have our maximum temperature and its distribution, which is nice, but we can then go back in and incorporate the minimum temperature as well and plot that on top of it. So if we were to flip the order of these two and put the minimum temperature a line above the maximum temperature, it would put the minimum temperature behind the maximum temperature on the plot. So think of this as this is your base layer, then you're going to slap something on top of that, slap something else on top of it, and continuing layering up using that. So when you add those two in, you then can also add in things like a title to your plot. X here, I can rearrange the X label and the Y label to be whatever I want them to be. I can rename them a variety of different things. And then on the side, we have this fill, which is our legend. And you can change that manually to be exactly what you want it to be. And then values here is going to change the coloring of those fills to be what we want. Because since maximum temperature, minimum temperature, it makes sense to do them as red and blue. I am putting those in there like that. If I didn't, ggplot standard is this paler red followed by, I think, green is the next color that they use, which is fine. You can use those. I just find that incorporating the specific colors that I want immediately can be useful for more intuitive analysis of the histogram. So I ran all of that together and then replotted it, and we get this back out. So you can see that in my X label is now temperature as a function of Celsius. And to get the degree symbol, I use this phrase right here to be able to get the degree sign. So that's one helpful hint, is that if you're ever using degrees for whatever, this can be a way of forcing the map or the graph to include that. And so that's how you can get it both in the label for the axis, but also as the legend as well. So that's just our histograms, but we can also look at what our data look like as point data or line data across the time period. So this is a new ggplot here that we're moving into. And once again, it's the same data set, but instead of using a geom histogram, we're going to use geom point. And this means that we're going to get point data out of our data set. And it'll plot it as points. And then I'm adding a geom smooth, which is effectively our linear regression or polynomial regression. If I wanted to, I can, let's see, it pulls up. Yeah. I can use a statistic to tell it various different things. I think it might be method that is the specific one to change the type of regression that you'd be using. But again, we're importing a point data and adding then a small regression line to it. So I hit Control R, that then creates a new ggplot item that has all of that data in it. And then I can simply hit that one again. It's going to take a minute because it's using a GAM method. And so here at the bottom, it's giving me a small note about what specifically the linear regression, the polynomial regression is being used. And so now we can see that plotted. So this is all point data, which is fine, great. And we can see long-term trends across the entire data set. If we wanted to look at it instead as a line instead of a point, we would simply use geom line instead of geom point. And the same data goes into it, the same syntax in the middle to achieve the same thing. So I can then rerun those. And again, it's going to take a minute to rerun the line, regression line. But you can then see that instead of being points, we have a line graph throughout the space. We type in here, just so you guys can see, there's a lot of different types of plotting that you can do within ggplot. There's an AB line, which is very simplistic linear regression. You can do area plots, bar charts, and bar graphs are used using GeoBar. You can do box plots very, very quickly. We'll just do a box plot just as an example. X equals T max in this instance should be all that's needed. And then I'm going to comment out these two. And that one. So I need to turn off that. Okay. So then that now creates a box plot for us. And so this is now a box plot with Tmax on the x-axis. You could invert this and say this is y is Tmax. And then you could flip it the other direction. Yeah. So now you have your median and then your quartiles on either side. So very quickly, you can shift around the types of graphics and plotting that you want to do within ggplot. So we can do the same again for minimum temperature, which is again those two that I showed you before. The way that you can then share these files and save them permanently can be through PNG for a PNG file. All of these are coming out of GR devices function. And you can then save them directly into a file folder. So I like to save them as PNG files. So the function is PNG, and then in there you need to tell it the file name, the width of the PNG file, the height of it to give it the dimensions X and Y, and then you tell it what it is that you want to plot, and then you have to put dev dot auth open close parentheses to end your file input in, or your image input into that specific file. So if you run this, it'll come back and tell you, it should come back with some sort of RStudio graphic design completion. And then it should appear in your, go to my working directory. I have it going in here right into my working directory. So my max temps underscore Phoenix PNG is simply the max temps that we had made before. Same with min temps, it's the same thing. And it will then update your file automatically once you've run that. So now you can see that my min temps file was just updated. It tells you the amount of the size of it and all, but that's nice to keep track of as you are exporting files. You decide, I want to change the title on this. You simply change the title, rerun the code to recreate the image, and then rerun the code to export it as PNG, and it will automatically update in the same location in your folder. So then if you have it like auto refreshing to a web page or to your manuscript, it'll automatically be changed in that, which is really helpful. At this point, are there any questions about basic data importation, plotting, and such?
I have a quick question. So all this has been so helpful, and particularly in terms of learning just kind of like the language of R, which is very different from the stats program that I use. This is like really basic, but the like looking at what the syntax that you have, like the temp.hist with the arrow and then the ggplot, could you just explain like that very basic line? So what goes before the arrow? What does the arrow do? The backwards arrow, what goes after that?
Yeah, definitely. So before it is what you're gonna want to call this thing. So it's effectively your variable name. So I'm calling it my temperature histogram because I know I'm going to put a plot in this variable name. And so then the backwards arrow is simply saying all of this data and analysis that you're doing, store it in this title. So if you wanted to say all of this is X or all of this is Z, you can use those as shorthand, and then all you have to do is just simply type X, and it reproduces that whole line of, or set of code. The only challenge with that is that X is very generic, and so you may want to save multiple things along the way in your script. This is all saving it simply within R. It's not saving it outside of R. So like thinking back, I guess like in high school when I used like a TI 93 or 83 or whatever calculator, there was the X stow button or the backwards arrow. It's very similar language to that, where you can simply store in a shorthand variable name for a bunch of things that you want to do. And it only stores it within the R script. It doesn't store it outside of R. To do that, you would have to write .csv or use a PNG file function to be able to export it outside of R. But this is all internal to R, saying under this set of characters, I want all of this code to belong. So it then runs the code and puts it and stores it as this. Does that make sense?
Yes.
Okay. I think you can also use a double equal sign. I think that's right.
Okay.
There's multiple ways of doing it. No, just one. Yeah. One equal sign can do the same thing.
Okay.
I tend to just use the arrow dash because that's what I was taught. But there are multiple ways of doing that. I also tend to space things out. Like I leave a space between the equal sign here. You could remove those spaces and just scrunch things up a bit tighter. For me, it's a bit easier to read, but some people have learned it the other way. I just tend to prefer things to be a bit spaced out. But yeah, you could use an equal sign in replace of the arrow dash, and it does the same thing.
Okay, thank you.
Yeah. Any other questions at this point?
Yeah.
Yeah.
I have one. So first off, thank you, because this is awesome. I wish you had like taught a whole course on this, and I would be the first to sign up. But so one of the things, so syntax is obviously big. That's probably where I struggle the most, but I'm getting better. But the other thing is kind of just how to export or how to generate some of the basic stats. Like obviously mean, mode, median, all of those are pretty standard and pretty easy. But say I wanted to do like interquartile ranges, or like, or kind of like if you wanted to take a set of data and just give me like the basic stats off of it, is there any way to kind of report, kind of like, is there almost like a package where I can say, okay, just give me the basic readout of stats, or like first moment stats?
So if I type in summary, so here summary is a generic function that produces result summaries of results of various model fitting functions. So you should be able to just simply go in and do a summary of this data set. You should do it just by one column, probably not by the whole data set. So let's just get a summary of maximum temperatures in this data set. This then gives you the minimum, the first quartile, the median, the mean, the third quartile, and the maximum. And it simply pops.
Sweet.
If you have done more analysis and maybe you're trying to do a summary of a statistical model or a linear regression, the summary of that would then look very different. So for example, to make a linear model, a basic linear regression, if you just want to look at the data, not plotting it out, we'll do daily.max.lm, short for linear model. And you would just simply put in LM, and then you'd want your formula. You would want to do, if you wanted to look at like a time change over time, you could do, it would be daily .max.min $sign Tmax, and then you use the tilde, which is telling it as a function of daily .min, .min, and then you're wanting to say maybe the date. And then you can do a whole lot more. The method could be a variety of things. I think basic one would be linear. Yeah, you could do like a Pearson correlation, I think, with that one. Oh yeah, so it's using QR. Because that one's. So that then creates that as another variable. So now you have a whole linear model just stowed away as that variable name that you can always recall within the session. So then if I do a summary of that, you then are getting a whole bunch of So it's saying, it gives you what that linear model is, and you're saying it's maximum temperature as a function of the date. It's giving you the residuals, coefficients, your intercept. You can get probability, statistical estimates of it, your t-values, standard error, S statistics, your R-squareds. You can see the adjusted R-squared super low because time necessarily, especially over 80 years, time is not going to be a great estimate of maximum temperature. Your residual standard error. I could change this and we could make it as a function of minimum temperature, which in theory, the two should be relatively highly correlated, but they're not going to be exact. So now your adjusted R-square is 0.8. So you're getting maximum temperature is predicted 80% of the time by your minimum temperature. So that's how you would run a basic linear regression and then get the statistics out of that.
That's awesome. Thank you. That perfectly answers everything.
Sweet. So I'll just save that so it's still in this R script, which is being synced with Google Drive so that if you were to go back to the email Maddie sent, you should be able to access this script with the updates in it. It may take it a second to resync, but it would be back up there. So any questions about this stuff at this point? Cool. Well, I'll move in a bit into some mapping. Let me go back to the PowerPoint. That's not the PowerPoint. There it is. Because I can show some variety of different things that I've done. There's a variety of different ways that you can do mapping. You can do it within ggplot. You can do it within tmaps, which is a different package, but functions grammatically and in terms of syntax very similarly to ggplot. You can import raster data sets and plot raster data as well within R. So you can do effectively anything that you would do in ArcMap, you can do in R. It just is going to take a bit more finagling and is a little bit less user friendly, I guess. But once you learn the language and the syntax, you can then reproduce anything you would have in ArcMap very, very easily. So these are just a couple examples of ones that I've done yesterday or the day before. I plotted the entire US, and then I plotted all the states that I've been to, as well as like major cities that I've been to. So you can quickly make these types of maps within R. This one is using data itself and is identifying where Arizona is, but then also plotting dots based on population size, the US cities that are all over, I think this one's like 250,000 or 500,000 people within the city. So R can plot all those things and create different ways of visualizing it as well. Some extra stuff that's in there, you can do some really fancy stats like principal component analysis, jackknifing, bootstrapping, as well as nonlinear regressions. You can also do qualitative stuff like chi-square analyses and the like. You can also access data through an FTP. So if you're getting stuff off a government website and it would be easier to get that data through an FTP, you can actually do that within RStudio in-house as opposed to having to do it outside in a regular bash or terminal. So that's another function within R that's helpful. So you can do stuff, again, this is from one of my previous papers, this is a bootstrapping analysis that I did. This one is qualitative analysis, moving toward chi-square analyses. This is just a basic map that showed us like all the locations of sites that we had within a specific location. But then we did a bunch of Kriging analyses, which is an interpolation process, and then remapped it across the city of Houston so that we could look at hourly ozone estimates across the entire city and do analyses off of that. So there's a bunch of different things that you can do within R. All of those take different types of projects or packages, and then also different ways of going about and doing them. So briefly, I'll just show you the places that I've been mapped and how I did that one. So we should have already downloaded all those libraries, but in case you hadn't, they're there. Map data has within it just a basic US data set. That within it also there's a states one and a US cities data set. And it has a bunch of information associated with them. If I were to look at like the US cities one, for example, it gives the name of it, what state it's in is a separate column, its population, its location, and whether or not it's the capital. So with the cities and with the states, I can then say all the cities that I visited, not all of them, but just like a subset of them. You can use the subset function, and rbind combines different things as different rows. So if I were to create this visiting cities variable, I can open that up and you can see then that row 1 is Seattle, which was the first one that I pulled, and so on. And then I can do the same for the states that I've been to. I can reproject all of that on top of a baseline US map. Oh, that was the wrong one. So there's a bunch of different things that you can play around with in terms of looks, and that's a lot of the theme stuff here. Fills and colors can be adjusting the coloring that you want to have. But then Geo and Polygon is within ggplot, and it allows you to plot out different polygons. So in this, I'm then pulling all the states that I've been to in my entire life, and giving it a bunch of information to shade them appropriately. So I take the US map that I had built before and add on all of those states, as well as adding in the visiting cities. And then it reproduces that map that I have been, places that I've been to. And so then fills them in and also highlights the borders of all the places that I've been, and then puts stars by each of the cities that I've been to. And the stars are all through this line of code here, line 143. So these are all things that you can do. You can also adjust the coordinate mapping that you want to use. So for example, in this one I just went with the baseline that was already the default one, but you can also adjust your coordinate mapping to be a conic one that is focusing on 30 degrees north, or you can make it a polar projection focused on different locations. So you can do a lot of different things with the mapping there. Yeah, so there's a whole host of things that can be done with the mapping, and this is all just baseline generic information that's publicly available. Are there any questions? I know this was like super brief on the mapping side of it. But each of these mapping packages, as long as you have the data, you can then rearrange and reincorporate things so that it can map those data sets. But are there any questions at this point? I know it's just after 2, so I want to be respectful of the intended hour-long workshop.
The only other one I would have, if I'm not taking anyone else's opportunities, I've asked a lot of questions, so it's more of fine tuning, and that's where I think I have the most trouble, especially with plots and maps and things like that, where I want to say, okay, move my legend up a little bit, left a little bit, get it out of so there's no overlapping of my data sets, stuff like that. And that's where I'm trying to figure things out a lot better.
Yeah. So within ggplot, a lot of that stuff will be within your theme set.
Okay.
So that's what I've highlighted here. You can create panel backgrounds and panel grids, and you can also adjust where those things are. Like with this plot title, I simply adjusted the size and told it I want it to be a size 32 title, and then a horizontal justification of 0.5, which puts it as a center justified title. So the HJust is going to be your horizontal justification. VJust is your vertical justification, and you can use that to at least initially adjust where your legend would be as well. You just have to do it with the legend settings within the theme. I forget exactly what that one, I think it's, yeah, so you can do legend box, which is the arrangement of multiple legends, the justification of it, margins around it, spacing, the direction, your key associated with it, etc. All of those are going to come within the theme of ggplot. I would also say that one of the good things about R being open source is that Google is really, really useful. And if you just Google how to adjust legend location space R, or if you know you're using ggplot, you could just say ggplot instead of R, and then you're going to get a lot of information from various people about how to adjust those things. And you can also usually find that on the Tidyverse website, also has several tutorials about those basics.
Okay. So like the HJust, for example, is that assuming that like the left portion of the map is 0, the right portion of the map is 1, and then 0.5 puts it directly in the center? Is that how that works? Or
I believe left is 0, right is 1, but let's just see.
Okay.
Adjusted from a 0.5 to a 0, and I'll, okay, so if I then replot that one, yeah, left just is 0, and then
okay, cool.
left would be right justified. So I'll go back to the,
Thank you.
yeah, no problem. Yes, that one's super helpful on the cheat sheets. I think,
Yeah.
is that the one that, I'm just gonna look and that's the one that I'm thinking of. There's also some tidyverse ones. Yeah, there's a bunch on that link. And I think some of them are tidyverse specifically.
Yeah, I have all the tidyverse ones downloaded. So
Yeah, they are super helpful. So the people that develop tidyverse as well, they publish in data science journals. And so like the tidyverse stuff is technically citable. Like you can cite specific analyses and ways of doing things within tidyverse because they're also researchers who have just taken the time to build this out for themselves, but then they've made it open source for other people. So yeah. Any other questions about our studio, other things that you can do in R? I'm working on a paper right now that's doing a lagged analysis of how temperature affects mental health and hospitalizations in Phoenix. So, and that analysis is all within R. So you can do even like time series analysis stuff in this.
Yeah, this was great. Thank you. I'm
Great.
working with a package called Open Air right now. That's actually kind of fun. It's one for looking at air quality over time. So you can plot time series of like air quality data. So I'm doing like PM10 and PM2.5 at some of my sites.
Nice.
For dust emissions. It's a really, really nice package. Pretty regularly kept up.
Yeah, I'm just looking at it right now. Like I just Googled open air package R and I can get the baseline stuff and it looks like, it's built on top of tidyverse.
Nice.
That's helpful because that means that your data set can be in a tidyverse type of format and it'll work just fine within the open air functions. Which also then should mean that your plot would be similar to the ggplot, even if it's not the exact same function.
Okay.
So yeah, all this stuff is open source material, which is just brilliant. So
yeah,
cool. Well, any other questions? I'd like to go back to my. There we go. Go back to this and just briefly say thanks, specifically to the School of Geographical Sciences and Urban Planning's Graduate Student Committee and Mehek as president of that for organizing, and also for you guys coming and virtually hanging out with me here today.
Thank you so much, Peter. This was really, really helpful. And thank you for volunteering to do this great, helpful workshop.
Brilliant.
I second that. Thank you. This was awesome. So
great. Well, I'm glad it was. Glad it was. And I'm happy to help answer any other questions. I may not be experts in your specific discipline or your data, but I can definitely help troubleshoot if packages are not functioning correctly and you just keep getting errors that you don't know and can't figure out. I'm happy to help troubleshoot on that as well. So,
awesome.
Great. Well, thanks so much, guys.
Thank you.
Happy coding, I guess.
Thanks, Peter.
All right. Bye, all.
Bye. Thank you.